All right, here's 74 from the Quarter 3 study guide. Each side of the square base of a regular pyramid is 6 inches. The face rises at an angle of 45 degrees from the base. Find the lateral area of the pyramid round to the nearest tenth. Okay, first off, lateral area of a pyramid. Remember, lateral area is simply the surface area, but without the bases. So surface area for a pyramid is 1/2 perimeter times slant height plus the area of that base that's on the bottom of the pyramid. Therefore, the lateral area is just 1/2 perimeter times slant height. Pretty easy. And what I recommend doing is just sketching out what this pyramid would look like. Okay, and they did say that all the sides were 6, right? So we actually already know the perimeter. It'd be 4 times 6. Right, because that distance right there is going to be the perimeter. So we know that's 24. All right. But we do not know the slant height. So how could I figure out the slant height? Well, they give me this other little piece of information that the faces rise at an angle of 45 degrees. So let's think about what we're talking about there. Let's draw a little triangle on the inside here, going from the top of the pyramid straight down to the middle, and then over to here, and then the slant height would be right there. All right, this is inside the pyramid, so let me try to resketch it so you can see a little bit better. Now you see my triangle, my right triangle, by the way. Let's redraw it a little bit bigger. What would this thing look like? Let's make that hypotenuse red because that is the slant height. What they're telling us is that this angle right here is 45 degrees. That's what they mean right there. It's 45 degrees. Well, if we had any other side length, we'd be good. Well, remember, this would be this value right here, or this point would be right in the middle. So that distance would have to be exactly 1/2 of 6. So that has to be 3 in this situation. All right, now I have a few options. One, what some of you might do, which is not the easiest way, but what you could do is you could say, well, this is like an adjacent, and this is like a hypotenuse. So you could start writing the equation that the cosine of 45 degrees equals the adjacent 3 over the hypotenuse L, and then you remember from when we did SOHCAHTOA that we could just swap these, and you could say, okay, so therefore the slant height is equal to 3 over the cosine of 45. Okay, boom, you could do that. And then we could plug that in, and we would have our lateral area. But what I'm hopeful that some of you guys would see in this situation is that this is 45 degrees, so that's actually one of our special right triangles. So this must be a 45, 45, 90. And if the side length here is 3, then we actually can just know exactly what this is, because the hypotenuse in a 45, 45, 90 is always just the side length times rad 2. So this is just going to be 3 rad 2. And in fact, if you were to plug this in your calculator and this in your calculator, you should get the exact same thing. So let's just go ahead and plug 3 rad 2 here. Like I said, again, you can plug this in as well. It's the same thing. And we're just going to go ahead and multiply in our calculator. So let's see, what do we get? Actually, what I would do first is I would do a little bit of work to get an exact answer, because 1/2 of 24 is 12. So that's 12 times 3. 12 times 3 is 36. So I got 36 square root 2. That's an exact answer. And we could say that's square inches. But if I needed a decimal, I could plug that in and get 50.91. I'm just rounding to 2 decimals. Oh no, round to the nearest tenth. Never mind, I want to do that. So 50.9 square inches. And that's it.